Hi, and thanks for joining. I'm Michael, co-founder and CTO of a company called Rethink, recently founded. Previously co-founded a company Container Solutions, which might be more known. Exited a bit more than a year ago. And today, we're talking about sustainable IT, green IT, or whatever you want to call it. Where we talk about how or what impact IT has on the environment and how to prevent that, or at least minimize that. Current state. We need to start somewhere. So DevOps, Cloud Native, however you want to call it, is, I guess, mostly accepted best practice, which doesn't mean everyone is practicing it, as with Agile. Compute becomes cheaper by the minute, and we have through cloud providers, at whichever you are, it doesn't matter. It's super easy to get access to compute resources, and many companies at the moment at least focus on developer experience. You can call it platform engineering. It's a big buzz at the moment, which optimizes for time to market, time to value. Which leads, on the other hand side, I mean, easy access, cheap resources lead definitely to overuse and inefficiency. I've seen a lot of cases where people just throw resources at problems, like, yeah, okay, this release adds, I don't know how many more percent in terms of resource consumption, doesn't matter, it's cheap, throw resources at it and continue, because it's cheaper to add servers than to actually work on efficiency or find why that happens, or find the bit of code that is actually causing this. The bigger problem with that is most companies do not understand which real impact it has. It's like a bit on the bill. Okay, fuck that. Doesn't matter. Usually it's insignificant usually to add just some more EC2 instance as well. Doesn't matter at the end. What kind of matters, and that's why a lot of projects get started in companies, it's of course now cost optimization, fine, scrap that, but it's also unmanageable. You have more and more growing infrastructure that becomes harder to operate. That's some concern. But the real problem, this chart everyone knows. I don't dive really into it. This is global CO2 emissions. But the main problem is 5% of those, that chart per year is caused roughly by us, IT professionals, IT, everything that is related to IT, software, infra, and the network in between to reach it. It's expected that this number goes up to 14% by 2040, which is not that far away, and does not yet include all the LLMs and AI stuff. At the moment, we expect that it goes up to 20+%. That's significant. That's more than air transport. Just to put it in perspective, it's significantly more than air transport. But the good thing is awareness seems to be growing. There is all kind of conferences now created. There's initiatives at companies. This is, who knows him? Werner Vogel's AWS guy. Quite famous, usually a quite nice guy, leading figure in the cloud ecosystem, I would say. But here is misleading. Cost is not a close proxy for sustainability. I can cut cost and make matters just worse. Imagine we are running our workloads here in Zurich, Switzerland, on Google or on AWS, doesn't matter. And I want to just cut down costs. It's one of the more expensive regions. Then I just go to North Virginia. I cut my cost by 30–40%. But also the energy mix in North Virginia is just the worst of all. Here it's one of the most green ones. So cost is definitely not a proxy. And there is no interest, of course, to reduce stuff. So they use cost as a, save cost and maybe by chance you will save emissions. If you turn it around, then you basically achieve both. If you put sustainability as a leading metric, then cost is a proxy. So sustainability is a proxy for cost because then you work on efficiency. And by reducing all kind of things, reducing the amount of servers, we come to that. So spare with that. But then you definitely save cost, but also save emissions. Today, I want to keep it simple. We start with infrastructure optimization, easy things to do. And then we go to software. Shout at me if you have questions. Please do that. There are 5 easy things to do, which basically everyone can do, no matter of, except one, on-prem or cloud. One thing is called zombies. Anyone with a meaningful IT, meaning a bit more than 10 servers potentially, has servers that are just running and no one knows about them. No one is ever logging in. There's nothing. And then after some years, you might identify them, and then most IT folks are afraid to switch them off because it could happen that someone uses it. Just turn them off. Wait for a bit. If someone screams, then potentially turn it on again. And if not, delete them. This process can, to a certain extent, also be automated. I mean, you know patterns of idle servers, so no logins, usually no network traffic, quite low utilization, and then you can kind of automate, at least on cloud, to basically stop that thing, and after X, whatever you accept, just delete them. Funny though, we have a customer that got informed by security that they have a machine constantly at 99% idling. Not idling, but 99% utilization, and they should check because it was quite outdated. And we thought at first, well, there is a miner running. It wasn't a miner. It was a load test they did start 3 years ago. The actual target was not in existence anymore, but the test did still run. It was a smallish instance, at EC2 instance, in an old account. But basically, it ran 3 years on 99%. We could calculate the emissions quite easy. That's significant. And the cost, well, of course, it was not needed, the thing. The load test was done. They just forgot to decommission the instances. And I had quite some of them. So legacy systems are things to consider. Security might know about legacy systems, so always good to also ask them, even though you want to know this for a different purpose. Right sizing. Industry average is below 15% of CPU utilization. So that doesn't matter if it's on-prem or cloud, but usually if you look at your whole fleet, I guess we are somewhere there, 15 to 25, that seems normal. Industry average is 15. Mainly coming from old days, on-prem days, where you had to purchase proper service once for all, and then they had to sustain also peak load, seasonal traffic, whatever else. So you had to do this actually to be like, okay, I need to prepare for the maximum and not for basically 90% or 95% of the time. But the ideal, I show graph later, the ideal of a server utilization lies beyond 80%, because then power usage, effectiveness, and basically the CPU utilization is at best. There is a thing called power usage effectiveness that's more for data centers, but there's now a new regulation in the European Union, at least, in place for new data centers with more than 300 kilowatt power usage, which is basically 2 racks and a bit of cooling. It's not that much. New racks or with high density servers consume up to 180 kilowatts in a single thing. Guess you can't power it at home. And the power usage effectiveness means 1.0 would mean all energy would go into the servers, and the 1. something, it needs to be better than 1.5 in the European Union. So cooling, all the other things for powering the data center need to become more efficient. And you only get there if you really utilize as well your servers that are hosted there. There are penalties then in 2 years from now, I think, in the European Union if you are not meeting that requirement. So I guess there's a bit of a motivation. If we utilize that high, then we still have potentially seasonal traffic or daily peaks or whatever else. And then there comes auto-scaling in place. So you should always max it out. And then if there comes, I don't know what kind of business you are in, but usually you have something like that during the day or special months or whatever, hype sales, some companies call it, when they have millions of people at one specific time accessing something scarce, like, we have a sports manufacturer's customer. They turn on a special shoe, only thousands of them are available at one time, and one day it takes roughly 30 seconds to sell them off, but millions of people want them. But still, auto-scaling is a thing. They wouldn't keep all the thing on stock. But if you are in that demand, your standard Kubernetes autoscaler won't do it. It's just too slow to respond. And there's pre-scaling or operators, or a bit smarter ones that use a bit more machine learning, connect to your scheduler that does basically the rollout of such advertisements and connect with them. But auto-scaling is a thing, and when the event is over after basically 30 seconds, throw them away. You don't need the machines anymore. There is technicality to it, of course. Your application needs to be able to scale. So state and stateless is a thing, but you can do it. It's not that hard. CPU architecture, who is running already on ARM? One. Did not expect one, but cool. Yeah. Not everything can run on ARM. This thing does, for example. Well, equal, but it's like a low power, low energy consumption with high throughput, but you can't do all. You need to build if you have Docker images or images, you need to rebuild them on that architecture. You also need to compile your code that it runs on there, but there's multi-arc builds, and also if you're coding Go, you can also compile, cross-compile and do things like this. Test it out if you like. Cloud, well, I put it there. AWS itself claims it's 3.4 times more effective. I don't trust that number, just to be clear. And they also have quite bad data centers like the North Virginia one, which is, I don't know how old, but they built them all over the place and they need to adhere to local registration. So if they pull it now in here in Zurich or Germany or wherever, they need to adhere to the newest standards. So if you go to the cloud and use one of those data centers, there is some efficiency gain you might have a hard time to build by yourself or find in your, I don't know, colocation center, which usually are also quite old. It's not just about green energy. So of course you could have a data center that is powered by the water next to it, but it's also about the embedded, I'll come to this later, what that means. So it's, of course, energy is one leading figure, but there are others. And if you take energy from the grid, someone else might not get it. So it's also a planning thing. What else can we do with hardware? That's not that long announced, I think. 3 weeks ago. I can't make it that much bigger, but Amazon published that they will extend their server lifetime from 5 years to 6 years. And they have quite a few of servers. They save 900 million in 90 days due to this. $1,000,000, dollars. There is something else to it. It's, as I said, not just about cost. Of course, that's a quite impressive figure. I'm not making 900 million in 90 days. But it's also about in the process of manufacturing a good, doesn't matter if it's a phone, a server, this TV, this stupid laptop, the whole production also takes energy and other goods in, and then there's this thing called embedded carbon. So embedded is whatever it took to finish this product and ship it to its destination. If they extend, and that's quite some million servers as it seems, by 1 year, less servers are produced, and so overall, just less carbon gets embedded, produced at other places, less resources. We also talk about resources. I'm sparing that out for today, but there's also, of course, resources like water, how you say, raw elements and other things in it. But today it's about carbon, that's why it saves dollars and carbon. It's not just for on-prem, mainly on-prem, of course, energy proportionality of a server. But if you have a VM, as I've said before, if you see here, is the utilization in red and the power usage of that thing. And of course, it goes through. At roughly 80% when the lines meet, there's basically where you should operate your servers on, because then they are at optimum. If they are not utilized at all, they already consume 50% of the energy. So that's a waste. Everything below that is basically just wasted energy, and it just generates heat. Questions to infra, what else to do? There are plenty of things more to do, but these are the easy ones, but the easy ones can take up to 50% of savings. So if you do this, and not just savings of emissions, but also it's real cost saver. So if you do right sizing, auto scaling, all kind of things that are kind of easy to do, then 50%. The next ones, there's a lot more to it, but it's harder. The software optimization is just slightly harder to do. But let's look at it. There's this thing, does anyone know Green Software Foundation? It's like the CNCF, it's also under the Linux Foundation, kind of new, 2 years old. They came up with the software carbon and intensity calculation. What does it mean? It's basically representing how much CO2 a process or an application, depends on how you calculate it, is consuming or emitting. It gives you a number, which is just a number that you can then use for monitoring and tracking. I will show an example. This is on their website as well, a big explanation there. You have energy, then this energy usually emits carbon somewhere. This depends where you run it on, where you are running. M is basically the embedded carbon, and then R, the functional unit. I have a small example. There's an Azure VM D8AS-V194, fucking hell, running at 50% for 24 hours and getting a bit of requests. Over this day, it consumed 1.87 kilowatt hours. That's not too much. And this energy in that region, there is a website called Electricity Maps. It's quite fun to look at and check it out. There you can find out the current, up-to-date, sometimes even in real time, depending on the energy providers, the energy mix and the carbon of that thing. But this emitted this, and now the fun part is, this is the embedded carbon for 1 day. So we assumed 5 years of lifetime of a server at Azure. We found out, it's public, it wasn't too hard to find out which kind of server it is. And there's so much embedded carbon in it that 1 day basically would equal to 855 grams. And then that's why extending lifetime is good, because you see the energy in proportion to the embedded one is not that much. And then we did 10 requests, we got to that result. What you can do with that is like SLI and SLOs. You can basically use this calculation. You can also do it dynamically. This one was, of course, for example purposes. But you could use this SCI score and apply it to all your application, all your things, and then put it in your, I don't know, Grafana, Prometheus, whatever you're using, and then alert on changes. So if a deployment gets out to production and you see it goes up, it's bad, so we need to look at it. If it goes down, hey, something got improved, also not bad. But you can form then, of course, service level indicators and then do an SLO out of this. And could use it as another signal for alerting, because it's steady. Question? Yes?
So I could use this to auto-scale, right? This, or not?
That would be quite custom. Of course, you could do it, but then you do not have the relation, the direct relation between the SCI score and the CPU utilization or memory or whatever, depending on your application. I wouldn't use it for auto-scaling. I would still look what is basically the leading thing. Is it memory? Is it queue length? Is it CPU? Is it whatever else? If you really, that's depending on what your application is. But I would use this as a way to first show that, hey, there is something. You go up, you go down. Efficiency score, maybe more into this direction. There's a tool, that's a green metric tool called. You could do this calculation, this SCI score. You, of course, need access to this. It's an Intel chip where you have access then through the host machine to read out RPA, is it called that way? So get the energy figures from the host. But then you could do this as part of your CI pipeline. And also do basically checks on it. Hey, did it improve? Did it go worse? And then basically fail a pipeline run if it got worse or not. The other thing was basically on production, like on live systems. There's a small ML model behind to also model then different behaviors. It's Python. The model is Python. It's quite simple. It's from a company called Green Coding in Berlin. Quite nice. Works. Try it out. It's open source. That's where the fun is. Who does profiling? Oh, tried it, played around with it. Okay, different question. Who knows what profiling is? Hey, cool. I come from performance engineering. So that's basically more than 10 years ago I did, when I still was developing software and stuff. I was working for a company called Holiday Check. That might be known. And we basically optimized already back then the software stack, and we had performance engineers. So we did not, this is Parser, it's also, I think, part of the CNCF. There are plenty of tools to basically just look at runtime, at your executed code. There are libraries, it doesn't necessarily need to be instrumented. You could also use here, for this example, it was just, we had a Kubernetes cluster, eBPF Cilium running, plugged it in, and then you get already something out. If you want to go deeper, then of course you can instrument your code, then you get even more. But what it actually does, it looks at your execution at runtime, and then this would go on and on and on. You get basically the results of each execution of things, and then you can dive into. And what you actually are looking at is where is time spent, so CPU time or memory. And through that, you want to find just inefficient code. We recently had a customer, and we did software optimization for them a bit here and there, and then we found a query, a database query that is just was executed, and then we thought, why is it always taking so long? Okay, it was executed millions of times, not too bad, it was okay. But what they actually did was the while loop to go over the result was done in the application, not on the database. It moved it to the database, 5% overall. Just 5% CPU was gone from the whole stack, and then plenty of others. What is also quite common is outdated or self-written libraries that are used all over the place, and then you basically see, okay, a lot of time is spent in those outdated or self-written libraries, and then you dig around what are they actually doing, and then you start asking questions like, why you are developing it by yourself? There's, I don't know, 5 to 10 public, open source, well-maintained libraries, and you can just swap them kind of out, and then huge gains usually. So on average, I would say, if you do this bare minimum, just look at outdated libraries, execution at runtime, memory leaks, you will find them. Another 20 to 30% won't use that time. Is easy. Easy in terms of course, this requires changes in code. So if you change the library or you change basically this while loop from in code to the query or in the database, a small change needs to happen. But yeah, that's how things are. But you will save another bit of CO2 emissions because less CPU gets required. You can, again, decommission some service, pack it a bit closer, and actually this improves reliability significantly because you will find weird memory leaks and other things. If you really dive into this, your code quality will just improve, the application will stabilize, no matter how stable it is already. If you are not doing this, I don't trust that it's predictably stable. Luck is potentially what I was going at. And then, that's the last exercise. This is a, can you actually read it? Or C. You see, C is basically benchmark. C is the most optimized language, and then it goes Rust.Go. It doesn't matter really, but look at, if you do Ruby, for example, it's almost 70 times more, it requires 70 times more CPU power and stuff than C, for example, for the same execution, for the same logic, for the same thing. So if you're anyway, so I'm never recommending a rewrite because a standard rewrite will always fail. But if you're anyway planning to, I don't know, for example, say I want to deprecate my PHP or my Ruby stack, do it in the right way. There are patterns for this, like, I don't know, the strangler pattern of Martin Fowler. So whenever you should touch something at the code or want to extend it, don't do it in the old world. Build it aside and put an API in between to basically communicate still with the old stack. But the typical way of, yeah, we don't do a feature freeze there and then we log away for 3 weeks, that will never work, trust me. But there is potentially the biggest leap is in here. If you really anyway plan for not just environmental sake to change your whatever you do to a more effective language, you will see the biggest leap in doing this. But this is the hardest bit, and it's a rewrite. So we know there's quite some risk in that. Do it right. Build new services just already in a new language. That's my recommendation. And build an API in between. And then go.
Pascal, because it's very well.
I was surprised by that as well, but I was also surprised with Java. But it's a highly optimized execution runtime. So it's around since ages.
If you use Spring Boot, it's gone.
That's true. Where's Spring?
But then there's memory, so.
I don't know where Spring is.
Memory is in the middle, right?
Yeah, memory, but that's what counts for us at least, energy. So CPU time. Memory is not that CPU intense, it's really the CPU.
JavaScript against TypeScript,
factor 5, so this doesn't
Yeah.
seem right.
Why? It's just an additional thing on top. So it's,
Not so much.
yeah,
I
but
think this is surprising.
I was surprised by that. By Java, I was really surprised. By all the other, I was like, Go, I would have thought a bit higher, but not a lot, because still, did someone do this? Okame? Fucking hell. That's a beast. So, sum it up, otherwise I get shot. Infrastructure savings, focus on this first. If you want to optimize not just for the planet, ideally yes, but also for the bugs, that's simple. This everyone can do, can be done on-prem and in the cloud, and it's super simple. Software, that's the next bit, without now talking about programming language. This is anyway what you should do. I mean, you should look at memory leaks, reliability, all that, but you can save another 20, 30, sometimes 40% on cost and on carbon. And, well, programming language. I'm never recommending a rewrite, but there is the biggest gain. So if you are really doing, if you have a Ruby shop, well, there is quite some savings, so might be worth the effort to invest in the rewrite. But do it well. Martin Fowler, Strangler pattern, read it up. It's a good way to go about it. All the others I've seen failing. Questions? Yes?
What about the operating systems?
I mean, you use purpose-built ones, so like small ones with less is more. Like use something like Flatcar Linux or something for your Kubernetes clusters, or one of the cloud provider mini core as in the past. Now it's Flatcar, however they're called now. Something like that. If you run on your host, well, you don't change the kernel but actually Linux kernel, and now some of the CNCF projects are basically at least continuous profiled and optimized for that. So recently there was a pull request by the guy behind Parser to the kubelet, and it stripped off 38% of consumption. The videos of this guy, Google or go to YouTube, check for Parser. They have a weekly or bi-weekly, it's called Let's Profile. Awesome. First to learn and also see, well, the kubelet one was quite impressive, I have to say.
Thank you.